The experiment which we are going to discuss now is about digital simulation of first order systems. And we're going to do this by using a MATLAB software. So to digitally simulate the time response characteristics of a first order and a second order systems with the sine, ramp and step input is what we are going to discuss in this experiment. Let me go to MATLAB again. The first step which you have to do is open up a MATLAB model. So for which you have to go to new, click on the Simulink model, a page will open for you people. And now we have to take up, we have to draw a block diagram. I'll show you what you have to draw. So this is what you're going to draw in this MATLAB. So for which you require a step input, a summator, a forward transfer function, a feedback transfer function, and a scope. So these are the components which you're going to use for forming this circuit in your MATLAB. So I'm going back to the MATLAB. Here you could see a library section, library browser. You just click on that, a block will pop up here. So the first one which you require is step input. So type step. So you will receive a step. Just drag it and place it on the model page. So first you got a step. Then again you go on to your library, click on type sum, you get the sum, drag it and just place it on your sheet. Again it requires a transfer function. So type transfer. You will receive a transfer function block. You have to take this block. There are various transfer function block. You have to take the one with 1 divided by s plus 1. A simpler transfer function block. Drag it and place it here. And you require one more transfer function block, which is feedback transfer function. Just Control C and Control V. And you have to rotate it. So Control R. Just rotate it. And then you require a scope. Type scope. Scope block. Drag it. So now I'm going to start giving connections. So I'm giving to the summator. So as you see, here you could see the summator is like plus and minus. So you have to do the same here. So double click on this. The block will open. You change it as plus and a minus. Give OK. So for which you double click on this plus and minus. Give OK. You will get the actual required plus and minus summator. And we connect it to this. Then again. You could see in the previous diagram, it has a step input and then response input. So there are two ports which is required for the scope. So now double click on the scope. A pop-up box will open in which you go to settings, give number of axes to be 2, give OK. So you get 2 axes and 2 ports. So you can connect it easily. So one for the input and one for the response. And now we can connect it back to this. That's it. So this is the connection diagram for this first order step input. So step input, a summator, a transfer function, a feedback transfer function, and a scope. Now what you have to do is you have to put the values of the transfer function, for which I'm going back to the experiment. I'm taking the question which is provided here. I'm just copying the question. Okay. So the question states 1 divided by s plus 1. Okay. So you click on this 1 divided by, for s coefficient is 1 and for 1 put it as 1. That's it. Similarly here 1 divided by s plus 1. In case if it is going to be 2 divided by s plus 1, just double click it and change it as 2. OK. That's it. If it is going to be 2 divided by 2s plus 1, you're going to give it as 2 divided by 2 and 1. So it's very 2s plus 1. It's very simple. So there are not much to be confused about this. That's it. Now we have to run. So just set this as 10 and run the whole circuit. Click on the scope and get the output waveform. So you could see step input and then its response. That's all. So this is what you are going to do for the other thing, like your other experiments also. So what I'm going to do is I'm going to replace this step. I'm going to replace the step input with a ramp input. So RAMP, I'm just typing the ramp. I'm taking the ramp block. I'm just connecting to it. For the same equation, 1 divided by s plus 1, for the same equation, I'm just going to run the experiment. I'm going to take the output. This is the ramp input and the ramp response. You can just zoom up and see. So ramp input and ramp response. You could see that ramp response changes here. So this is what we receive for the ramp. And similarly, you can do it for the other one, sine. I'm just copying it. I'm deleting the ramp and just typing, dragging my sine. Simple sine wave. Run. Simple sine input and sine response. Sine input and sine response. That's all for the first order experiment. And now similarly you can use the same circuits for doing your second order as well. So I'm going for the second order. So this is the equation for the second order. So 1 divided by s square plus 4s plus 5. So same. I'm going to give it here. 1 divided by s square plus 4s plus 5. So coefficient of Abraham. I'm just going to do it for all and then run it together. S square plus 4s and 5. Okay. And for the denominator, we could do this given by 1 divided by s plus 1. So I'm not changing it. 1 divided by s plus 1. I'm just leaving it as such. So I'm going to run and then check the responses. So this is for the step response. And this is for the sine response. This is for the ramp response. This is for the second order. So depending upon the equation which is provided to you, you can substitute in the numerator as well as the denominator, and you can solve the whole experiment. So this is about your first order and second order response digital simulation using step input, sine input and ramp input.